Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session, we will see how we can prepare our board to apply power. What are the necessary parameters to be checked before connecting power? It is called cold testing. First of all, we need to verify the power bank. If this board has high voltage capacitor, high capacitance, for example, this is 450 volt, 560 microfarad, and it is a huge bank. In the first step, we need to verify its safety. If there are any type of voltage on the board, it must be discharged. Check DC voltage here and never touch any component in this power area, in this DC rail, until we are confident that it is fully discharged. If you have any type of voltage, you can discharge using lamp, soldering iron, or you can make a very simple discharging kit. These 2 points I connected 20 kilo ohm resistor between these 2 points. It will provide slightly slow discharge. When we are confident that there are no voltage, then we can touch this board. These all checkpoints, that is my routine. It is not documented anywhere. This is the process which I do in my routine work. When we are dealing with any power components, then visual inspection. Any loose, anything loose, any burnt item, if there is any burnout, blast, smoke, discoloration, especially in the power area. If anything is discolored, there are smoke signs, there are burning signs, anything is damaged, blast, we need to verify. This is loose component. Then this capacitor is damaged, dent, bent, damage, like that. If there is any sparking sign, sometime if already there is some work done, verify that. If any solder droplet is making short circuit to next closer component, these are visual checkpoints. Like here, an external component is connected, diode here. Some work is done here. We will start cold testing. In cold testing, first of all, we check input resistance. To perform cold testing and input check, we need to analyze the board. What is the configuration of the board? As I discussed in my last video, that we need to make a sketch, block diagram of the components. In last video we completed sketch here. Now we will make connection here. This is 220 volt in. That means this is input area. This input connector and these 2 input connectors. This is 220 in. We have one input in this portion. Here we can see small bridge rectifier. That means this section is dealing with low power. Here is small capacitor for 450 volt. So this is dealing with low power. And if we check this area, it have large bridge rectifier, so that means more current in this area. And finally, here we have UVW out. For input resistance check, first we need to verify the fuse. If there is any fuse, verify that fuse. This fuse is good. If anywhere the fuse is burned out, that means that area is already exposed to high current. If fuse is good, that means there was no overcurrent condition. Now check resistance at input terminal. It is 840 kilo ohms. If this resistance in ohms are 100 ohms, 100, 200 ohms, that circuit is not safe. If it is above than 100 kilo ohm, that's good. You can verify by reversing the leads. Also check here at these two terminals. So this area is safe. Initially this circuit takes power, then this area will activate power on. After that, when it will receive command, at that time this IC and this soft starter will start working, then it will connect this power. That time bridge rectifier and other components will come in circuit. But now in this condition, our first start point is here. Then we can verify the high power area. High power components at the input, we have this bridge rectifier. Set multimeter to diode. If these are safe, then test power stage. Either it is input and output, both stages. Most of the time there are problem in input stage or output stage, at power stage. This is cut side, that is positive output terminal. At positive output terminal we will connect black lead. Remember that black lead is connected at common point, red lead at positive terminal. Now black lead at positive pin, connect at center pin 0.47, 0.47. Reverse the leads. Open, open. Good. Now move black lead to negative terminal, that is here. That's good. Now reverse the leads. Red lead at negative terminal, AC input terminal. That means this bridge rectifier have no short circuit, that's good. Okay, now check IGBTs. These points are our UVW output. Connect red lead at positive terminal of the capacitors. Good continuity. Check with U out, V out, W out. Reverse the leads at the same point. U, V, W. Now move black lead to negative terminal of the capacitor. U, V, W. Reverse the leads at same points. upside and downside safety diodes, body diodes are working good. Now check here between UVW. That's good. That means there is no short circuit in this stage. This is cold testing, and in cold testing, if we detect any component like this condition or this damaged component, we will replace it. Now I will replace this capacitor and this capacitor. In upcoming session we will apply power and we will verify step by step the function of this board. If this video is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching.